So inverse trig functions, let's do these 4 examples and talk about what an inverse trig function is. First of all, that's what this is, arc. There's 2 ways to write it. You can write arc sine, or you can write like sine inverse, like that. They mean the same thing typically. Some books teach them as a little bit of a different concept, like one of them deals with maybe degrees and the other one deals with radians. I don't know, but to be honest with you, they're all roughly the same thing, so I'm going to treat them as the same thing. But the idea is this: the arc sine literally means the angle. This answer is the angle whose sine is -1/2. The angle, and really I have to give it even a domain. The angle, or I should say a range. It's the angle between -90 and 90, or -π/2 and π/2. And why do I say that? Why do I have to say that? Well, because if you think of the arc, if you think of a sine graph, remember what the sine graph looks like? It goes here, and then it just keeps going, right? This is essentially the inverse. And you remember what you do with inverse functions? You remember how you take the inverse of a function, you flip it sideways? Well, if I flip this whole thing sideways, it's not going to be a function anymore. If I flip this thing sideways, it's going to be, flipping it sideways, it would be flipping it over this line. It's going to be going like this, which isn't a function anymore. So I have to restrict it, and I could restrict it. There's really a couple ways I can restrict it, but what they're going to choose to restrict it for the arc sine, they're going to restrict it from here to here. So this part of my graph is what I flip sideways. And so it's still a function. It's still a function to flip it sideways. So this is from -π/2 to +π/2. And I'm looking for where the sine is -1/2. Well, where's -1/2? It's right down here. Here's -1/2. So I'm looking for this value. I'm saying, what's the value where the sine is -1/2? Now, where does it equal -1/2? Well, look, it equals it here, here, here. It equals it in a lot of places, but I'm only looking in that yellow restricted range area. So what is that? Well, go to your unit circle. Here's my unit circle. Look only between here and here, because it's from -π/2 to +π/2, and look where the sine is equal to -1/2. And that is the value right here. Now, you don't write 11π/6, right? You write -π/6, because 11π/6 isn't in my range, my restricted range. Does that make sense? So your answer is, for this, the angle between -π/2 and +π/2 whose sine is -1/2. And what's the answer for that? -π/6. So there's your answer. Okay, so there's the explanation of it. Now let's do these a little bit quicker. So this is asking, number 2 here is asking the tangent inverse of (1/√3). The tangent inverse is defined in the same place that the sine inverse is defined. It's defined between, hold on. So it's also defined this is also defined from -π/2 to +π/2. So what angle has a tangent of 1/√3? Again, go back to look at your unit circle. It's in that same area. What angle has a tangent of -1/√3? Well, that's going to be the same value, -π/6. So it's also -π/6. Now it gets trickier, because sometimes you get something like this where I'm not using the unit circle. So this is saying, let's interpret what this is saying. This is the angle whose tangent is 7/24. So arc tan, this is some angle, right? This is the angle whose tangent is 7/24. So we have to write that. We have to draw that picture out. That's going to be in the first or fourth quadrant when the tangent is positive. It's going to be in the first. So 7 over 24. The tangent is 7 over 24. That means the opposite is 7 and the adjacent is 24, because that's what a tangent is. So this is my angle right here, right? This is my angle. And what would this side be over here if that was 7 and 24? This is a
25.
Very good. 7, 24, 25. Very good. So now the question is, what's the cosine of that angle? And now and that's why I drew the picture.
Yeah.
The cosine is adjacent over 24 over 25. There's your answer. So it's not on the unit circle, but you can still find it.
Right, so just using right triangle stuff.
This one is on the unit circle. So this one is saying, now this is where people think, oh, well, the arctan is just the inverse of tan. These would just cancel each other out, right?
Yeah.
So your answer would be 13 pi over 6, right? Kind of. What's the only problem with that?
You can't do 13 pi over 6, so it's just pi over 6, negative pi over 6.
You have to find out where 13 pi over 6 is and make sure that your answer is in the yellow area.
Yeah.
So 13 pi over 6 is right here, right? So that's the same as just regular pi over 6. So your answer is actually not 13 pi over 6, it's positive pi over 6 because of the range restriction on the arc tangent function. One last thing, the arc cosine function is restricted to from 0 to pi.
Okay.
And the let me think. Is it 0 to pi, or do I have to include one of them? Let me think about that. So that would mean it's from here to here, and the cosine is the first one. So no, actually, I have to include those. It's actually like this, including 0 and pi. Same for the sine. It's between negative 90 and positive 90 inclusive. But the tangent one, I don't think is inclusive because I think the tangent is undefined. Yeah, the tangent is not including them because it's not defined in those two areas. So this one is open. Make sense?
Yeah.
And the arcsecant would be the same as that because it's like the cosine. Is that right? Arcsecant. Again, let me think it through. Except it would not include the secant cosine. Wait, no, that's not true. Because the cosine... Nope, I think I said that wrong. Because the cosine is undefined at pi over 2. So the arc cosine would be... I'm sorry, the secant would be... Let me think about that. So let me just show you real quick what these are. So the sine inverse function, the range, like I talked about, is from negative pi over 2 to positive pi over 2. The cosine inverse function, the range is from 0 to pi, inclusive. The tan inverse function, I should say, of x, is from negative pi over 2, not including, because it's not defined, it's from negative pi over 2 to positive pi over 2. And then the cotan inverse of x is going to be from 0 to pi, not inclusive, for the same reason of the tangent. And the secant, let me do cosecant first. Cosecant inverse is going to be from negative pi over 2 to 0, not including 0, and then from 0 to positive pi over 2. In other words, it's it's the same as this, but it can't include 0 because it's not defined at 0. And the same with the secant inverse function. It's the same as the cosine function, but it doesn't include pi over 2. So it's from 0 to pi over 2, union from pi over 2 to pi. So those are the ranges of your inverse trig functions.